Assalamu alaikum everyone. I am Hafsomar from Maths Online Coaching. Today we are going to solve a question paper of Pearson Edexcel International A-Level Mathematics. Pure Mathematics 1, January 2026 with paper code WMA1101. Question number 7. The curve C has the equation y is equal to 2 by 3x cubed minus 8x square plus 43x minus 20 by 3. Part A. Show that dy by dx can be written in the form p into x plus q whole square plus r, where p, q, and r are the constants to be found. Here the equation of the curve is given and we have to find out the derivative and then convert it in the form px plus q square plus r by using the method of completing square. So let us start the solution. Part A, y is equal to 2 by 3 x cubed minus 8x square plus 43x minus 20 by 3. Now differentiating both sides with respect to x, we have dy by dx is equal to 2 by 3x square by using the power rule of differentiation minus 8 2x plus 43 1 minus 0. This is equal to 2x square minus 16x plus 43. This is the derivative of the given equation. Now we have to convert it by completing square method in the given in the required form. 2 is common, x square minus 8x plus 43. Take common only from the variable part of the value. Now, in completing square method, we take the half of the coefficient of x. Coefficient of x is 8, and when we take half, it is 4. Now, add and subtract 4 square. 4 square minus 4 square plus 43. This is equal to 2 times x minus 4 whole square minus 16 plus 43. This value is converted into the whole square by using the formula here. This is equal to 2 times x minus 4 square minus 32 plus 43. And it gives 2 times x minus 4 whole square plus 11. Now this is the derivative in the form p x plus q square plus r, where the value of p is 2, q is equal to minus 4, and r is equal to 11. It completes the solution to part E. Now look at part B. Part B is hence take the minimum value of dy by dx. And number 2, the value of x at which this minimum value occurs. To take the minimum value of dy by dx, look at its value. Part B 1. We have to take the minimum value of the derivative, and we have dy by dx is equal to 2 times x minus 4 square plus 11. Now to take the minimum value, we'll look at the square value. X minus 4 whole square is a non-negative value, and the minimum value of it is 0. This term must be 0 to take the minimum value. And if we take this one equal to 0, then the derivative will be dy by dx is equal to 11. So this is the minimum value of the derivative. In part 2, we have to take the value of x for which this minimum value occurs. This minimum value occurs for x minus 4 is equal to 0, which gives x is equal to 4. So this is the value of x for which the derivative is minimum. Next is part C. Find, given that S is the point on C at which the gradient is minimum. S is the point which lies on the curve with minimum gradient. Find the equation of the tangent to C at S, giving an answer in the form y is equal to mx plus c, where m and c are the constants. Here S is the point which lies on the curve at which the gradient is minimum. So for the point S, the value of x will be 4, as it is the point where gradient is minimum, and this point has abscissa of 4. X is equal to 4. To find out the value of y for S, we have to put it in the given equation for y. The equation for y is 2 by 3 x cube minus 8x square plus 43x minus 20 by 3. Using x is equal to 4 in this equation, 4 raised to power 3 minus 8 times 4 square plus 43 times 4 minus 20 by 3. This is equal to 2 by 3, 64 minus 8 times 16 plus 172 minus 20 by 3. And this is equal to 80. So y is equal to 80 at point S. The point will be 480. Next is to find out the equation of tangent to the curve at this point. So equation of tangent in the form y is equal to mx plus c can be determined by using the value of gradient here. Now the gradient of the tangent is same as the gradient of the curve. And S is the point where gradient is minimum, so the minimum gradient is m is equal to 11. The gradient or slope of the tangent is 11. Now using these values in this equation 1, y is 80, gradient is m, the value of x is 4 plus c. It gives 80 minus 44, and this is c is equal to 36. Using this value of c in equation 1, we have y is equal to 11x plus 36. This is the required equation of tangent at the point S where the gradient is minimum. It completes the question. Stay with us for further solutions.